Good morning, dear children. We can continue the lesson work, energy, and power. Okay. And last class we have discussed about the collision and two different types of collision, that is elastic and inelastic collision, isn't it? And today's class we can discuss in detail about the elastic collision in one dimension. Okay. We can study about the elastic collision in one dimension. Okay. Elastic collision in one dimension. Here we are considering two objects A and B. Here actually these objects A and B are elastic objects having masses m1 and m2. Then object A that moves with velocity u1 and object B that moves with the velocity u2 along a straight line. And here we are assuming that u1 greater than u2, greater than u2. Okay, so A and B that collide each other. Okay, after that object A moves with velocity v1 and object B that moves with velocity v2 along the same direction. Okay, actually these two get separated after collision if v2 greater than v1. If v2 greater than v1. Listen it. Here we are considering two elastic objects A and B having masses m1 and m2. And object A move with velocity v1 and object B that moves with velocity u2. And here we are assuming that u1 greater than u2. So A and B that hits each other or collide each other. Okay. And after collision, A moves velocity v1 and B moves velocity v2 along the same straight line path. Okay. And the condition here is v2 greater than v1. Isn't it? And actually this is the condition of before collision, and this is actually during collision, and this is the case after collision. Okay. Next we can apply conservation of momentum. Law of conservation of momentum. You know, in elastic collision, the momentum is conserved. You know, last class we have learned. Okay, the momentum is conserved. That is, total momentum of two objects, that is A and B, before collision is equal to total momentum of two objects after collision. Isn't it? That is actually the law of conservation of momentum. Total momentum before collision is equal to total momentum after collision. Okay. Then when we consider the object A, it has mass m1 and it moves with velocity u1. So its momentum is m1 u1. Listen it, its momentum is m1 u1. Then when we consider the object B, it has mass m2 and it moves with velocity u2. Then what about its momentum? Mass into velocity, you know. So m2 u2 is its momentum. Okay, that is the momentum of object A before collision is m1 u1. Then when we consider object B, its momentum is m2 u2. Then what is the total momentum actually? m1 u1 plus m2 u2. That is the total momentum before collision. m1 u1 plus m2 u2. Isn't it? That is the total momentum before collision. Then after collision, you know, A moves with velocity v1 and B move with velocity v2. Then what about the momentum of object A after collision? It is m1 v1. Then what about the momentum of object B after collision? m2 v2. Then what is the total momentum? m1 v1 plus m2 v2. Okay, m1 v1 plus m2 v2. Okay, so here the according to the law of conservation of momentum, total momentum before collision is equal to total momentum after collision. So we can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. That is actually equation number 1. Listen to it. Next is actually here m1 u1 is here and this m1 v1 that comes on LHS. So it becomes minus m1 v1. Okay, we can write on terms on side. So m1 u1 minus m1 v1, that is equal to here m2 v2 and here m2 u2 that goes on right side. That becomes minus m2 u2. Listen it, here m1 u1 minus of m1 v1 is equal to m2 v2 minus m2 u2. Here actually, which is the common term here, common M1 is common here. So M1 taken out. So M1 into U1 minus V1, that is equal to, here the common is M2. So M2 into V2 minus U2. Isn't it? Here M1 is common, so M1 is taken out. So M1 into U1 minus V1, that is equal to, here M2 is common, so M2 into V2 minus U2. Let it equation number 2. Okay, that is actually equation number 2. Actually, we reached equation number 2 by applying the law of conservation of momentum. Or we can say, in the case of elastic collision, you know, momentum is conserved. So momentum before total momentum before collision is equal to total momentum after collision. Listen to it. Also, you know, in the case of elastic collision, kinetic energy is also conserved. The kinetic energy is also conserved. That is, the total kinetic energy before collision is equal to total kinetic energy after collision. You know, what about, you know, the equation for kinetic energy? What is the equation for kinetic energy? You know, half mv square. Half mv square. And when we consider the object A, it has mass m1 and it moves with velocity u1. Then what about its kinetic energy? Half m1 u1 square. Half m1 u1 square. And when we consider object B, its mass m2, then it moves with the velocity u2. Then what about its kinetic energy? Half m2 u2 square. Then what is the total kinetic energy before collision? Half m1 u1 square plus half m2 u2 square. Half m1 u1 square plus half m2 u2 square. Okay. Then after collision, object A moves velocity v1. So its kinetic energy is half m1 v1 square. And when we consider object B, it has velocity v2. Then what about this kinetic energy? Half m2 v2 square. So the total kinetic energy is half m1 v1 square plus half m2 v2 square. Okay, actually we can cancel this half and we can write m1 u1 square plus m2 u2 square equal to m1 v1 square plus m2 v2 square. Listen to it. And we can rearrange in this equation as m1 u1 square. Here it is. Then this m1 v1 square, that comes left side. So m1 u1 square minus m1 v1 square, that is equal to, here m2 v2 square. Okay, and this m2 u2 square, that goes on RHS, so it becomes negative m2 u2 square. So we got this relation, m1 u1 square minus m1 v1 square equal to m2 v2 square minus m2 u2 square. Listen it. And here we can take m1 is common. So m1 is common. Next we can write u1 square minus v1 square, that is equal to, here m2 is common, so m2 into u2 square minus v2 square, u2 square minus, sorry, v2 square, v2 square minus u2 square. Listen it. And here actually this is the form of a square minus b square. Okay, you know a square minus b square is a plus b into a minus b. That thing you know. Here it is u1 square minus v1 square. So that thing can be written as u1 plus v1 into u1 minus v1. So we can write m1 into u1 plus v1 into u1 minus v1. Okay, next this is v2 square minus u2 square. How we can write v2 square minus u2 square? Actually it is v2 plus u2 into v2 minus u2. Okay, v2 plus u2 into v2 minus u2. Let it equation number 3. Okay, actually this is equation number 3. Next we can divide equation 3 by 2. Okay, actually equation 3 is this one. Equation 3 is m2, this one m1 u1 plus v1, then u1 minus v1 is equal to m2 v2 plus u2 into v2 minus u2. Then we can divide equation 3 by 2. Actually this is equation 3. So m1 u1 plus v1 into u1 minus v1 divided by, here it is m1 into u1 minus v1, that is equal to m2 v2 plus u2 into v2 minus u2 divided by, here it is, m2 into v2 minus u2, isn't it? And this m1 cancel, and u1 minus 1, u1 minus v1, and this u1 minus v1 cancel, and the remaining is u1 plus v1, that is equal to, here m2 cancel, then v2 minus u2, here v2 minus u2 cancel, and the remaining is v2 plus u2. Okay, so we got, by dividing equation 3 and 2, we will get u1 plus v1 equal to v2 plus u2. Okay, u1 plus v1 equal to v2 plus u2. And by rearranging this, we can write u1 minus u2. Okay, here u2, here it is. When it comes left side, it becomes minus u2. So, u1 minus u2 equal to, here v2, this v1 goes right side, it becomes negative v1. So, v2 minus v1. Listen it. Here it is v1 minus u2 equal to, u1 minus u2 equal to v2 minus v1. Okay, u1 minus u2 is equal to v2 minus v1. v2 minus v1. Actually, this is u1 minus u2, actually that represents u1 difference u2, or u1 minus u2, that represents the relative velocity of A. U1 is the velocity of A object. So, it represents the relative velocity of A with respect to B before collision. Relative velocity of A with respect to B before collision, that is equal to relative velocity of B with respect to A after collision. Isn't it? So, in the case of elastic collision, the relative velocity of one object with respect to other before collision is equal to the relative velocity of the second object with respect to first after collision. Isn't it? In other words, we can say the relative velocity of approach. Here A approaches B. Okay, so the relative velocity of approach is equal to the relative velocity of separation. Here actually it gets separated after collision. The two objects get separated. So the relative velocity of approach before collision is equal to the relative velocity of separation after collision. Listen it. In the case of elastic collision in one dimension, the relative velocity of approach before collision is equal to the relative velocity of separation after collision. That is actually here we proved here. Listen it. In the case of elastic collision in one dimension, we proved that the relative velocity of approach before collision is equal to the relative velocity of separation after collision. Next, we can find the expression for velocities of the two objects, two bodies after collision. After collision, the object A that moves with velocity v1 and the object B that moves with velocity v2. Okay, so we have to find equations for v1 and v2. Okay, that is the velocities of two bodies after collision, or the velocities of the two objects after collision. Isn't it? Equation 4. Actually, equation 4 represents the velocity of the relative velocity of approach, that is equal to the relative velocity of separation. That thing you know. This is the equation 4. u1 minus u2, that represents the relative velocity of approach, that is equal to the relative velocity of separation after collision. So we can write u1 minus u2 is equal to v2 minus v1. From this we can write v2. Okay, from this we can write v2 as u1 minus u2 plus v1. Okay, v2 is here actually, then u1 minus u2, and this minus v1 come to this left side. It becomes plus v1. So we can write v2 is equal to u1 minus u2 plus v1. And next we can substitute the value of v2 in equation 1. Okay. we can substitute the value of V2 in equation 1. Equation 1 you know, but is equation 1 actually where we applied the total momentum before collision is equal to total momentum after collision. That represents actually the equation number 1. So we can write m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Isn't it? And here in the place of v2 we can substitute the value of v2 here. So instead of v2 we can write u1 minus u2 plus v1. Isn't it? Other terms remains the same. Only instead of v2 we can substitute what u1 minus u2 plus v1. So we can substitute here m1 plus v1 plus m2 into, instead of v2 we can write u1 minus u2 plus v1. The next we can remove the bracket. So we can write m1 v1 as such, then m2 u1 minus m2 u2 then plus m2 v1. Just we remove the bracket. That will we did here. Okay, m2 u1 minus m2 u2 plus m2 v1. Isn't it? Actually next step is actually, here we know m1 u1 is here. m1 u1 is here. And actually here it is m2 u1. Isn't it? Here m1 u1 and here it is m2 u1. Okay, so we take this m2 u1 to left side. So it becomes, here it is m1 u1. And when this m2 u1 that came in LHS or left side, it becomes minus m2 u1. Isn't it? Here m1 u1 is here. Here it is m2 u1. We take this m2 u1 into the left side. So it becomes minus m2 u1. And here it is u1 is common. That is taken out. So u1 into remaining is m1 minus m2. So here is m1 minus m2 into u1. m1 minus m2 into u1. Isn't it? And next we can write here m2 u2 is here. m2 u2 and here it is minus m2 u2. So here it is m2 u2 and when this minus m2 u2 that came in LHS, so left side it becomes plus m2 u2. So we got m2 u2 plus m2 u2, that becomes 2 m2 u2. Isn't it? That becomes 2 m2 u2. Okay, and the next term is actually, here it is m1 v1 is here and here it is m2 v1 is here. Okay, here m1 v1 plus, here it is m1 v1 plus m2 v1. Okay, here it is m1 v1 plus m2 v1, which is common actually v1. So we can write m1 plus m2 into v1. Isn't it? Here m1 v1, m1 v1. Here it is m2 v1, which is common actually v1. The remaining is m1 plus m2. So here it is m1 plus m2 v1. Isn't it? And here we have to find the value of v1. That is the velocity after collision. That thing we have to find v1. So we can write v1 is equal to, we can write v1 as, v1 is equal to, here it is. So we have to divide this left side by m1 plus m2. Then only we will get the value of v1. Isn't it? So v1 is equal to, here m1 minus m2 divided by m1 plus m2 into u1. u1 is here it is. Next term is here 2m2 divided by this m1 m2, remaining here it is u2. So we got the value of v1 as m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. Then next, in order to get the velocity after collision of the second object, we have to exchange the subscripts 1 and 2. Isn't it? So instead of here, instead of 1, we have to write 2. Then instead of 2, we have to write what? 1. Okay. So we got v1. Then we have to write v2. v2 is equal to, here it is m1 minus m2. We have to exchange 1 by 2 and 2 by 1. So we got m2 minus m1. m2 minus m1. The denominator remains the same because it is m1 plus m2. Then instead of u1, we have to write u2. We have to just interchange the subscripts. Okay. Instead of u1, we have to write u2 plus here 2m2. That becomes 2m1 divided by m1 plus m2. Then u2 becomes u1. Okay, we have to just interchange the subscripts. That is, in the place of 1, we have to write 2. Then in the place of 2, we have to write 1. Okay, so these are the velocities of two objects after collision. That is v1 and v2. Listen to it. That is v1 is equal to m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2. Then in order to get the velocity of the second object after collision, we have to just interchange 1 by 2 and 2 by 1. So we get m2 minus m1 divided by m1 plus m2 into u2, then plus 2m1 divided by m1 plus m2 into u1. Okay. Okay children, that is the end of today's class. Also we have finished the lesson and problems are remaining. I think we can do on the next class. Okay, thank you children.